Okay, so it's been a while. Um, Unfortunately, I got sick right before break, and when I came back from sick leave, it was basically break because I had to catch up with everything I missed. So again, apologies, but let's kind of pick up where we left off. So factors, is this a factor? So basically, by doing a factor, what we're doing is we're plugging in the answer to this. So if we plugged in the 1, we plugged it in, we got 0. Is x a factor? So is x a factor? Oh, I think what they're doing is they're just continuing this by saying, is x a factor? Well, that would mean that x equals 0, so we plug in 0. I think I had that realization when I was last time I was reviewing the video before doing this one. So now let's get into the actual work to check if this works. So in order to see this, we're going to see, is this a factor? So we're going to have to plug in -1. So what I recommend doing is open up a tab. Let me move this over here close to this tab. I know I have a bunch of tabs open. Um, so what we're going to do here is we're going to open up a tab and open up Desmos, which, oh, I haven't even opened up Desmos in a while. Huh. So we're going to open up Desmos, go to desmos.com, and we're going to use not the graphing calculator, we're actually going to go to Math Tools and use a scientific calculator. This allows me to input a lot more than I would on the standard calculator. So I just need to remember this. So I'm not going to remember all of that. Let me temporarily move this tab over here so I'm able to look at it on my other monitor while typing it in. And we're plugging in -1. So in place of that x, I'm going to put -1, and I'm going to put to the, what power was it? To the 4th power. Okay. So that's to the 4th power. And in case you guys forgot how to do that, you hit this button right here. Or what I do is I do Shift 6. So hold Shift and 6 at the same time. What you're doing is, when you do that, is you're hitting this little, they call it a caret. I call it like a little up arrow. So by doing Shift +6, you do this up arrow, and on most programs, with the exception being Edmentum, because Edmentum is special, um, it creates this exponent. And then you want to use your little arrow key on your keyboard to go to the right, otherwise you're stuck up here. I don't know if you can see my cursor up here with the exponents. So we're going to do that. -4, we're going to put parentheses because there's an x right here. I'm going to do Shift 6 to put the power of 3. And then we're going to do -7, parentheses, -1. We're going to do Shift 6 for the power of 2. And then we're going to do +10, parentheses, -1. Do that there. And this gives us a -10. So what that tells me is no, it is not a factor, because this should be equal to 0 if x plus 1 was a factor. Let me write that down. So if x plus 1 was a factor, we're saying that x equals -1. So similar, before I said, is x a factor? So that would just literally be x equals 0. So you would plug in a 0. If you get 0, it works. So in this case, no, it is not a factor. So let me drag this back from my other monitor. So we're going to say that no, it is not a factor. Now, why did I ask you? Oh, this is equal to -12. So because it's equal to -12, it is not a factor. Now, why did I ask you guys to use Desmos instead of just, oh, we'll just use it one time, it's fine. Well, now we have to do it with -2. So if we plug in -2, that's saying that x plus 2. So the factor would be x plus 2. Um, the x itself would be -2. So the factor is x plus 2, but the x itself is this -2. So here are the x's. Here's what the factor would be. Is it a factor? Well, I told you guys to use this Desmos. So now what we can do is instead of using -1, we're going to change all of these -1s. Oops, I got rid of my parentheses by accident. Remember, the negative goes inside the parentheses. If it's not inside, you're going to lead to problems. So I'm going to change this to a -2. I'm going to change this 1 to a 2, making it -2. Change this 1 to a 2, making it -2. And I'm finally going to change this one. And right here, we're getting 0. So that means that if I input a -2, I should get 0, meaning that the term x plus 2 is a factor. So that works out. And you can see that they're plugging it in. They're showing all the steps, but I recommend just using the scientific calculator. It's going to save you some time. All right, moving on to the next one. So this is just saying if the x is this, the factor would be this. Is it a factor, though? I should say term, because I do not know if it's a factor yet. So is this expression, this term, a factor? Then we can answer that by simply saying if we plug it in. And these are actually the answers to that question. All right, so we're going to do this thing called synthetic division. So instead of having to plug all that stuff in, we're going to use this process called synthetic division. And it's actually my favorite way to solve polynomials. It's really interesting how intuitive this is. So synthetic division, let's say we wanted to plug in, so we have this expression. Let's say we wanted to plug in, so the first thing before we do synthetic division, you have to count for every power. So notice how there's no 0, there's no x to the 4th here. You have to kind of consider that a 0. So whenever there's something that's not there that you know should be there, just pretend it's a 0, and that's how you're going to do synthetic division. So in this case, we want to plug in, so these are our coefficients. I'm getting ahead of myself because I'm like, I want to get to the synthetic division part. So what we want to plug in, we're going to try to we're going to see if this is a factor. So if we're seeing if x minus 3 is a factor, we're saying that x equals 3. So we're going to plug in a 3 here. So what we do here when we're doing synthetic division, they do it kind of differently than I do, but that's fine. For the first one, we have no multiplication. So we're going to bring down a 1. And I don't know why I'm saying this because I'm literally going to do it in the next screen, but we'll see it right now. So give me a second. Let's go to the next screen and start solving how to do this synthetic division. All right, so we're going to bring down that 1. And then in the next one, we have to do 1 times 3. Well, 1 times 3 is 3. So right here, we're going to put 3. And then we have to add these two. So 0 plus 3 is 3. Next one, we're going to do 3 times 3, which is 9. We're going to fill that in there, add it, 0. So 0 times 3 is 0, so we put a 0 here. 1 plus 0 is 1. So basically the one thing you're not showing is we're doing a little plus sign here for all of these. And then this goes over here, gets multiplied by this, and that's going to create the next term. So all of these are multiplication. We did not have anything here, obviously, because it was the beginning. So that's how come this is just an arrow going down. All right, so let's do this. So here, what ends up happening is our answer is 0. So in other words, f of 3 is equal to 0. And we can actually do other creative stuff, like we can bring this down and we can say if we're dividing this, and it is going to explain it, Edmentum is really slow when it's explaining stuff. We can say that if we're dividing by x minus 3, we can say it divides out nicely, and this is our answer. Well, what do I mean by this is our answer? This is just a series of numbers. Well, remember that trick that we did where we were talking about these? We just brought down the coefficients. Well, these are coefficients of our next term. So this is you always start from the bottom going that way. So start off with 3. We start off with our constant, and it's a positive, so I put a positive. We have a 1. So there's a 1 there, but I don't really like showing 1s in front of things, so I'm just going to put my x, because the next power is x. The next power, and it's a positive, the next power after that is an x squared. Well, in front of that is a 0, so we're going to basically cancel that out later, though. And it's x0 is not neither positive nor negative, so we're just putting a positive there just to show we're adding. And the next power would be x3. So we're increasing powers going this way. And x3, well, the coefficient there is 3. We see that here. And the next one after that is x to the 4th. And the coefficient for that is this 1. So we're just leaving it as x to the 4th. And we can rewrite this as x to the 4th plus 3x cubed plus x plus 3. I basically just got rid of that 0 in front of that x, or I basically got rid of the x squared because we're multiplying it by 0 anyways. And we'll see that right now. So give me a second. Let me erase all of this. So it is a factor, which we already established because it's 0. And on top of that, we're going to show our answer. So that's our answer. That's the one that I said earlier. You guys can rewind it if you don't trust me, but notice how that x squared isn't there. All right, so basically, this is the reduced polynomial, original reduced polynomial. I think this is us dividing by 3. Yeah, this is us dividing by that x plus 3. Oh my gosh, I have to do all of this. Or x minus 3. So that's us dividing by that x minus 3. I don't know why they call it a reduced polynomial. It's not really reduced. We just factored out that x minus 3. And then we can continue doing factors by trying other numbers. So let's see if we can find another factor. So we want to figure out if this is a factor, this x minus 1 is a factor. Well, instead of doing it again, we're going to do it by what's left over. And we see all the process, how we did it. We got an 8. So we know that x minus 1 is not a factor because the final number after synthetic division is not a factor. So instead of plugging this 1 into the original function, we already factored it out. Let's plug it into the factored out function. They call it a reduced one, but it's more of a factored out already. We already factored something out. So again, here's this factored out one. We already factored out that x minus 3. And now we want to see if positive 3 is a function, if x plus 3, not positive 3, if x plus 3 is a factor. So in order to try x plus 3, we're going to do an x minus 3 through the synthetic division. And the reason for this is we're saying that x equals negative 3. So let's try our synthetic division out. And we do get a 0. So this means not only is x minus 3 a factor, x plus 3 also happens to be a factor. And now we have a brand new reduced polynomial, as they call it, reduced polynomial. Well, this one we can use the sum of cubes formula, which I have it memorized, but I know it's really hard for you guys to have it memorized. I have it memorized because I have years of math experience, but I do recommend you guys go back to your notes and do the dose formula. So dose, if you guys forgot, was a minus b times a plus b is the same thing as a squared minus b squared. This difference of squares. The next one is technically you can do sum of squares, SOS, and this one you might need help on because SOS, but you might need help on it because of the fact that we have imaginary numbers here. This is this a minus bi times a plus bi. And then now we're doing cube. So this is soc and doc. Doc, the formula was a cubed minus b cubed. The way it starts off is always the same. So notice how, oh, I kind of messed these up, SOS up, but help me, SOS. So this one, you always kind of want to start it off with whatever the symbol is. So a minus b times a squared plus ab plus b squared. It's always going to end up with a plus b squared. Next one is sum of squares. So I call it SOC, which is this one. Notice how it starts off with that a plus b, but now the second symbol is the opposite. Same thing here. It started off with the same symbol, but the second symbol is the opposite. And I'll go back to mouse mode so you can see it a little better. So this symbol is the same. This one's opposite. This symbol is the same. This one's opposite. And I don't know if you guys noticed, I did get a bigger mouse symbol so it's easier for you guys to see it. It's also easier for me to see it since I have two monitors. So those are formulas I do want you to memorize. Those SOS to a lesser degree, it's more going to happen when we're dealing with imaginary numbers. Doc for sure, because now we're going to be dealing with cubes, and soc for sure. So looking at this, we have a soc because it's a sum of a cube. So that's how come we're able to get this other factor out of it. And you can read this to see the sum of cubes right here. So we had that x minus 3 as a factor, we had that x plus 3 as a factor, and we were able to factor out sum of cubes here, which ended up being the cube root of x cubed is x, the cube root of 1 is 1, and then that x squared is x squared. We do a negative because it's the opposite of what we're doing. So it's 1 times x is negative x. Technically it's x, but we're putting a negative symbol there. And then 1 squared is just 1. So that's what we get there. And in case you're wondering why this is always a plus sign, well, guess what? Even if b was negative, when you square it, it ends up being positive. So that's why it's always a plus. All right, so recall and identify these by using the remainder theorem. So the remainder theorem is in case we're ever dividing by something that doesn't factor out, you're just going to put that little remainder there. I'm going to leave it here for right now, just because I know this is a lot to take in and you might want to review this for a bit. And I will finish. Ooh, that's still a lot left. Let's kind of, that is a lot, but I don't want to make the third video super long. So we will continue on a little bit more. So we will do this unit activity. I was hoping to start off the unit activity, but we're going to keep doing this. So here, we're going to see what happens. So we're going to pick all the factors. So all the factors have to be where if we plug it in, it is equal to 0. So this is our x, this is our y. If our y is equal to 0, that's a factor. And I was supposed to leave this unanswered, but I hate how I left it kind of there. So that was my bad. So if our x is minus 5, well, that means that our term is x plus 5. So x equals minus 5, that means the term is x plus 5. It's kind of the opposite. The next one is negative 3. So that has to be x plus 3. The next one is this x minus, or x plus, x equals 4, which means it's x minus 4. And the interesting thing you'll note here is, see how this one goes from a positive to a negative? Well, if there's a positive here and a negative here, at some point in time it has to cross the 0. So this negative 4 and this negative 1, at some point in time, we cross the 0, which happened at negative 3. I know that's a more complicated idea, but just to kind of show you, there's this 240 here at negative 4, and then at negative 1, we're at negative 240. So at some point in time, it had to have crossed this 0. And that just so happens to be at negative 3. This is not drawn to scale, but you kind of get the idea, hopefully. And if not, like I said, this is a more complicated idea that you'll learn about later. So I'm going to submit those. It's right. So now we're going to use synthetic division for this next one. So if we use synthetic division, we're trying to test these out. So we're trying out the 2. This tested out. And so synthetic division used right polynomial, divisor, and remainder. The new function that can be used. So we're going to say that f of 2, or is it f of 2 or is this a different function? F of p of x. P of x is our original function is what they're saying. So p of x, let me use a different color here. P of x is the original function, as they call it. F of x is our reduced function. R is our remainder. So remainder, original function. And this is going to be our reduced function. So if we plug in 2 into our function, we're going to say this is equal to 0. And it wants us to do our reasoning, so we're just going to say by synthetic division. They already did the work for us, so I don't know why they're asking us to present our answer. R is 0 because there is no remainder. Or another way of saying it is x minus 2 divides into p of x. So what I'm saying there is it divides it nicely. It divides our original function nicely, so there is no remainder. That's another way of saying it. And then our function. So our function, remember, we always start from the right and go to the left. It's a little backwards that way. So we're going to start off with 9 as our constant. And then we're going to have 0x. So we're going to put that 0 there. And then for the next one, we have this negative 10. So it's negative 10 and x squared. And then I'm going to keep kind of alternating colors. So then we have a 0 here. So that's going to be 0 x cubed, and we can just put a positive number there for now. And let me do kind of like a purple color here. And then we have this 1, so that's going to be 1 x to the 4th. So our function ends up being, and unfortunately, we're going to have to use this equation editor to write it down. But luckily, it still shows my work here. So I'm going to write this down as x up 4. I'm going to ignore that x cubed, so I'm just going to move on to x squared. I'm going to ignore the x because there's a 0 in front of it, so I go to 9. And I can just put this in here. And, oh, I forgot to say, this is our f of x, our reduced function, equals that. Using numbers from synthetic division, and placing x's in order from right to left instead of left to right, right to left. It would technically be ascending order if you want to get technical. Ascending means getting bigger, so I'm saying getting bigger from right to left. And it's ascending order of power. And we're starting at 0, so that's why it's a constant. X to the 0 is just 1, so that's how come this 9 is by itself. So I'll submit that there. All right, because the number is left to or to the left of the remainder, new polynomial. I don't even know what it's saying here. That's why I kind of like how I said it. We're using the numbers from the remainder, the coefficients, and we're inserting the powers. This doesn't even talk about putting in your powers. All right, so which one of these are coefficients? So we know one of them for sure, or which one of them are solution. We know one of them for sure is 2. Oh, uh, da, 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 da. Oh, it's a completely different one. Oh my gosh. Um, so this is a good spot to end off on after we finish this one. So for this one, what we're going to do, first of all, let's try seeing if there's any missing. So there's no missing. It goes 0, 1, 2, 3, and 4. So we can put our exponents in. And this does it a little differently than I do synthetic division. I normally did synthetic division this way. They do it the other way. So I'm going to try doing it how they did it just so I don't confuse you guys. Let me just erase everything right now. So I don't confuse you guys. I'll do it the way they do synthetic division, which to me is weird and strange. So they do 1, 4, 1, 4, -7, -22, and +24. Okay, so obviously the first one's an arrow. And then I have to try something. Well, my possibilities are -1, 6, and 3. Oh, I see a 6 and 3. So I can kind of use these to start off. I'm going to try with x -1. So that means I have to try out a 1. I'm going to do this in a different color because I might have to erase this stuff later. So I'm going to do 1. So let me do a better color than that. Let's do red so it really stands out. Well, it's going to be too similar to the other. Let's do blue so it stands out. We're going to try 1. So 1 times 1 is 1. So I'm going to put that here. I'm going to add it. So there's a line here that I'm adding. And that's going to be 5. So 1 times 5 is 5. So this is -2. -2 times 1 is -2. So -22 plus -2 is -24. And this is -24. When you add them, it's a 0. Yay, it worked out. Cool. Awesome. So now what we're going to do, so we're going to say that this is definitely an answer. Cool. So now what we're going to do is we're going to try another answer. So we're going to try this here. If this doesn't work, oh, let me do it with red because that submit button's really kind of hampering this right now. We'll go with red. All right, and I will use green, I guess, for the other color. So let's try another factor. Let's try, I feel like if it's the first one again, then Edmentum's just giving it to us. So I'm going to try a +6 right now, just to see. So, oh, go back to my pen. So +6. So first off, I'm going to get a 1. This is a 6, so I get 11. That's 66. Oh, so this is already too big for me. I'm already uncomfortable with how big this is. So, oh, and actually I wrote this red line way too far down. So give me a second here while I fix this. The line should have definitely been right here. And all right, so I tried the 6, so maybe I should go with what Edmentum's giving me. It was getting too big, so I'm going to try the -1 now. I'm going to try that x +1. Watch, it's going to be the top one, and I just kind of try to metagame, and then it metagamed me. So I'm going to try -1. So I have to bring down the 1. 1 times -1 is -1, so this becomes a 4. 4 times -1 is -4, so I'm going to bring that down. This is going to be -6. -6 times -1 is +6. Oh my god, it did metagame me. And this is 18. So that is not a factor. So I'm willing to bet I tried to metagame them and they ended up metagaming me back. So hold on. So I'm erasing all the red. You didn't have to color code it. I just made it easier for me to tell what I need to erase afterwards, which came in handy. So we're going to try +2. So 2, we're going to bring down this 1. So that's a 2, or 1. 1 times 2 is 2, which makes this a 7. So that's 14. So this is -12. Oh my gosh, it feels like it would have worked out if the numbers were different. Oh, that's a +12. What am I doing? Come on, Victor. Think. It's a +14 minus 2. That's 12. So this is 24. So that's 0. So this is a factor. And it would have had to been because we tried all the other options. So I'm going to try to stop metagaming. Let's do the first one. So it's a +3, so we're going to try a -3. So if x plus 3, so we're going to try a -3. So I'm going to switch back to blue to show what I need to erase. So we're going to try a -3. We're going to bring down the 1, -3, add those, that's a 4, -3. Oh my gosh, Edmentum's literally being nice to us right now. I think what they're doing is, I wonder if you got the first one wrong, it would kind of keep going on as the wrong answer. So this one we get 0. And from here, it's actually really easy to solve. So we know this one is that x plus 3. So now we're left with this expression, which is actually really easy to solve because it's x plus 4, which means that x has to equal -4. So this was a much easier way of factoring. So if x is equal to -4, we have this x plus 4. And let's submit it. And they're all right, of course. Then you can see all the work that they did. All right, so let's evaluate this. So honestly, most of you might have trouble with it. I'm going to give myself a 4, just because I was not paying attention to the function in, what was that part in question 3, in Q3, and almost went off of that factor and got confused. So that's why I kind of ding myself a little bit on that. It's supposed to be how you feel you understood the material. So that one just confused me a little bit. If you're having trouble understanding how to do synthetic division, again, feel free to make an appointment with me or comment on the YouTube video if you're watching this on YouTube, and I can try to explain it a little more. But self-evaluation should definitely be how you feel you're understanding the material. If you take the time to evaluate what you don't know, it narrows it down to how you can learn it. So don't take these lightly, guys. Really write down what you do not understand to help make it easier. All right. And with that, I will leave this video, and hopefully we'll finish the last couple slides in the next video.